Hey, feeling good, like I should. When in dark, walk around the neighborhood. Feeling blessed.
Alrighty, let's check and see how well you did on your homework last night or yesterday. First, we're going to start with the M&Ms, and we have the angle sum theorem for triangles, which I was referring to as the triangle sum theorem. That basically states that in any triangle, the total sum of all three angles, measure of angle A, measure of angle B, measure of angle C, is always going to add up to 180 degrees. Now, they've shown us a slightly different kind of a proof for this than what I showed you in the lesson the other day, I guess yesterday. Here we've got ourselves a triangle, and if you duplicate it a couple times and then flip it around, you can see that this side forms a straight line, this side is a straight line, and these two lines are parallel to each other, which makes angle B here an alternate interior angle to the original angle B, and you've got angle A here, which is alternate interior to the angle A here of the original, which means that they're congruent to each other. So when these are all laid side by side, angle A, angle B, and angle C form a straight line, which means that they're all supplementary, which means that they have a total sum of 180 degrees. So yet another proof for triangle sum theorem. Okay, getting into angle pair relationships. This is kind of going in the other direction. The other day we talked about how when a transversal intersects two lines that are parallel to each other, the corresponding angles are going to be congruent to each other. The alternate interior angles will be congruent to each other, and the same side interior angles will be supplementary, meaning that they will add up to 180 degrees. So what we're going to do is we're going to go in the opposite direction and say, all right, if we know that two angles are in fact equal to each other, have the same measure, for instance, angle 2 and angle 7, then we know that the line that they share in common, the transversal, must be intersecting two parallel lines. So that's what's happening in this case. Since angle 2 and angle 7 are alternate interior angles of a transversal, and they are congruent, then the two lines of the transversal is intersecting must be parallel to one another. Now let's take a look at angles 11 and 3. Okay, so these two angles are corresponding angles on a transversal. And since it says they are equal, then that means that these two lines, line E and line F, must be parallel to one another. For angles 1 and 12, they're not on the same line. So there's really no conclusion that we can draw about any of these lines when they're not on the same transversal. So there's no conclusion to be made there. Angles 13 and 12, okay, well, these happen to be alternate exterior angles because they're on the outside of the parallel lines. But you could also say that angle 13 is congruent to angle 10 because they are vertical angles. And angle 10 and angle 12 are corresponding angles. And so if 13 is congruent to 10, then 10, and 13 is congruent to 12, then 10 must be congruent to 12. Therefore, these are corresponding angles on a transversal being equal, and lines C and D must be parallel to each other. And then the last example has supplementary lines. What is it, 6 and 7? Here's 6 and 7. They're on the same side interior of a transversal. If they add up to 180 degrees, that means that line E must be intersecting two parallel lines. So that means that C and D are parallel. Please feel free to back this up and listen to my explanations again. If I went a little bit too quickly or if it didn't quite sink in the first time, you can rewatch this video multiple times to help with the corrections to your homework if you need to. All right, let's take a look at some different examples here. We've got two angles that are supplementary together, or supplementary to each other, which means that the total sum of these two angles must be 180 degrees. So if I take 132 plus 2x plus 3, I'm going to say that those are equal to 180 degrees because I know that they together form a straight angle. So you would combine like terms, subtract 135 from each side, then divide by 2, and we get x is equal. I'm not sure that that's right. Hold on for a second. Let me show this work. So that is going to be 135 plus 2x is equal to 180, which means that, oh yes, we're subtracting 135 from each side. Yes, 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 yes. So that means this must be 45. If 2x's is equal to 45, then 1x must be 22.5. Now we could check that to make sure that works. If this is 2x's, then this must be 45 plus 3 is 48, and it's 48 plus 132 equal to 180. I think it is. So that verifies that we've got the answer here. Correct. Here we've got an exterior angle, and we've got two unknowns in a right triangle. So I know this one's 90 degrees. There's no question about that. And I can figure out what this one is because this is supplementary to the 131 degrees. This must be 49 degrees. So now I can use triangle sum theorem to figure out what do you add to 49 to give you 90, because you know these two combined plus that 90 have to equal 180. Turns out angle E is 41 degrees. And then this is your exterior angle, external, exterior. So that's always equal to the sum of the two remote interior angles. So you add those together and you get that angle. All right, everybody, should practice their fraction operations, dividing and multiplying. I'm just going to do these first two. Whenever you divide fractions, you always keep the first one as it is and multiply times the reciprocal of the second one. Now, you can maybe do some cross cancellation along the way, or you could have just multiplied straight across and simplified, but you get 20 over 7, which is the same as 2 6/7. So when dividing fractions, multiply times the reciprocal. When you're multiplying fractions, it's the easiest thing in the world to do, and this is a wrong answer. I know for sure that's wrong. I can tell right away because 50 is the product of 10 and 5, so it's supposed to be negative 50 on the top and 143 on the bottom, and I believe that's in the simplest form. There's no reducing that. So once again, these are fractions. You'd multiply times the reciprocal. Here you got a negative times a positive. So you're going to get a negative answer. Here is eventually going to become a negative times a negative once you multiply times the reciprocal. And that again is going to give you a positive answer. If I ever do not fully explain how to solve a problem and I just move on and you have a question, please do not hesitate to send an email. I will work through those problems. These are pretty straightforward, sending in the dive bombers here and then solving for x. Probably D is the one where students may struggle, so let me work this one out for you. 2x minus 5. Okay, so I don't want to deal with that fraction, so I'm going to choose to multiply every single term times 4 so that the 4 cancels out with the 4 here, leaving you with 3 x's. Nothing cancels here, so it becomes 8 x's, and nothing cancels there, so that becomes minus 20. So now what do we have to do? Now let's, I think I'm going to just subtract 8 x's from each side, even though this is going to give me a negative. That's okay. That'll be done in one less step. I'll have negative 5 x's, which is fine, and minus 20 on the other side, negative 20. So what number do you multiply times negative 5 to give you negative 20 for an answer? Well, I believe that number would be 4. And sure enough, negative 20 divided by negative, no, divided by negative 5 is equal to 4. Okay, what's the difference between simple interest and compound interest? Here we're looking at, there's our principal, $45 that Joaquin has agreed to lend his younger brother. And it looks as if both of these situations have the exact same interest rate and the same terms for the number of months. The only difference is one of them is simple interest per month and the other one is compound every month. So it does not surprise me that the answer to the compound interest is a little bit more than the simple interest, because that's what we learned about the two different types of interest. Compound interest applies interest to previously earned interest, so it's going to grow more quickly. So what do we have here? Let's take our 2% interest rate and change it to a decimal number. We've got our principal, right? Principal goes here. The interest rate goes here. And then the time in years is not years, it's in months, goes here. So you multiply everything together, and it looks like, let me go ahead and work this guy out in blue, 45 times 2%. I wonder what 2% of 45 is. 45 times 0.02 is 90 cents. So that means that this is 90 cents per month. And then for 6 months, put in the 6 here, times 90 cents, and that's going to be $5.40 is the amount of the interest alone. So you take this, and they're saying how much will Joaquin get back? Well, he's going to get back his $45 plus the additional $5.40 is how you get $50.40 here. For the compound interest, what are we going to do? I guess I've got everything written in there. We take our 2% interest and we add that to the 100% of the principal plus an additional 2% compounded 6 times because it's once per month. And then you multiply that times the 45. So let's see what we get here. I'm going to take in my calculator 1.02 raised to the power of 6. This gives me like 1.1261624 blah, 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 blah. So I'm going to take that and multiply it times the 45 now, because remember, order of operations, you have to do this, the exponent operation first before multiplying. You take that, multiply that times the 45, and it gives you a decimal number, about 50.67730, but let's just round it to 50.68. And that's what we have for our answer there. So sure enough, compound interest grew more quickly than simple interest. Martha is saving money to buy a new laptop that costs $1,800. So let's see, she's got $200, and then she plans on saving an additional $150 per week. So that's where she starts. That's her y-intercept. And then the amount that it's going to grow per week is $150 per week, where X is the number of weeks and Y is the total amount of money. So if we were to put this into a table, you could see, okay, starts with 200, then it goes up 150 every single week. And we could keep going until we see, okay, somewhere in here is where she's going to reach her goal for $1,800. I'm guessing from 1700 to 1850, it's probably going to be 2/3 past 10, so 10 2/3. Let's take a look at how this would look on the graph. Y-intercept is at 200, and then it grows by 150. And once you get to here, does that look like it's about 10 2/3? Yeah, looks like it. I'm going to go ahead and solve this problem just to verify that the answer is 10 2/3. So our goal is to get to 1,800, and we're saving $150 per month. No, per month? Yeah, month. And we started with 200. So I'm going to take away the $200 from the 1,800 because that's going to tell us how much she needs to make over this time period, or save, I should say, since she's saving $150 per month. Now I can divide each side by 150 and take out my trusty calculator. And let's see, 1,600 divided by 150. And yes, it gives us 10.6 repeated. So that's what I was expecting, is right around 10 2/3 right there. Was there a question there that we had to ask? Yeah, it's constant growth, blah, blah, blah. Okay, good. Is that it? We're done? All right. Well, hopefully you've been doing all your work this week. We've got a Friday assessment. I would like for you to go back and review as much as you possibly can, and then click onto that Google form and show all your work in your journal. Do the best you can and make sure that you feel confident about your answers before you submit. You should get immediate feedback on your score. All right, take care.